Okay, so how do you write an equation for this? Now the trick is, it's weird. You can write an equation for this using sine or cosine. Okay, now this one, when you get used to it, the sine function would be easier for this one because the starting point for sine is right there on the y-axis at the origin. So that would be the easier one to pick. So that's what I'm going to pick first. We're going to first do, let me explain the template too. Here's your template for the sine function. Y equals alpha, A times sine times omega times x minus h, and then plus k. The A and the W are the only letters that change the shape. A is your amplitude. I know, if you already wrote this, it's fine, you don't have to write it again. And W is what changes the period. And actually, this would be good to write down too. It would be good to write down the period equation. Period equals 2 pi divided by omega. And then you have H and K. H and K, they do shifting. So the H does hori shifting. That's horizontal shifting. And K does verti shifting. That's vertical shifting. What you have to remember with the shifting is that the hori shifting, you always have to think opposite. Okay, so I'm just going to write opposite right here in parentheses. Think opposite when you're hori shifting. Now we're first going to do a sine equation for this line. And then we'll do a cosine equation so you guys can see the difference. Because cosine and sine both have the same y values on their graphs. They just have them at different times. But they're the same shape. So if I was doing sine, I would write this. And I would think one at a time what each letter could be. So I'm thinking about A first. So if this is the sine function right here, what would my A be? In order to know that, you have to know the midline. Now, this function doesn't look like it moved up or down. The midline is on the x-axis. Okay, the x-axis is our midline for this function. So what is the distance from the midline to our maximum? It is quattro. If I count, it would go 1, 2, 3, 4. The distance to our maximum from the midline is 4, so our amplitude is 4. Now the next number I got to consider is the omega. So that's this guy right here. That's the one that changes the period. So what is the period for this? Now this is why I don't like this picture that much, because some of you guys might have gotten lost on this number right here. Do you guys know what that number is?
That's pi.
Well, that is pi. 3.14 is pi, so this could have said pi right there. So what would this number say if that number was pi? That would be pi over 2. Okay, so to find our period, you have to trace it and see when we complete a full cycle. Right there is when we complete a full cycle, before we start repeating ourselves again. So what is the period for this graph?
1.
It is 1 pi. Okay, so what we do is, since we know the period is 1 pi, we're going to, on the side here, we're going to say 1 pi equals 2 pi over omega. Because we have to know what our omega is. Now to find our omega, some of you guys can look at that and tell me right away. Oh, that's a 2. Because if you have a 2 right here, then you would cancel those out and then you get pi equals pi. But let's say that you couldn't figure it out. Let's say it looks more complicated than that. Okay, so pretend with me that this looks complicated and you can't see it right away. This is what you do. Make the pi into a fraction. And then, this should look familiar. You guys remember cross multiplying?
Oh, yeah.
We're going to go pi times w. So that would be pi w equals, what is 2 pi times 1? It's 2 pi. Okay, so how do I get w alone? I divide by pi. Divide by pi again. So what does w equal?
Pi.
Yes. Now w can also be called omega because, you know, it's like Greek and everything. So I'm going to put 2 right here. And then normally I would put 2 outside parentheses. But I'm not going to right now because is there a horizontal shift? Do we have an H? No, and I know that because our starting point is right where it's supposed to be on the y-axis at the x-axis as well. And so we have no Hori shift. Is there a verti shift?
No.
We can tell verti shifts by looking at the midline. Did the midline move up or down? No. Not Doug. So it's done. We just got to put the 2 right here. That's it for sine. Now you can leave it like this because there's no adding or subtracting. But if parentheses just make you feel better, you can put those there too. It's the same thing. Remember I said we can write a cosine function for this instead. Okay. Now we're going to have to think a little differently on this one because now with the cosine function we actually do have a horizontal shift. So let's see. Let's do this in. We'll do it in purple. Yeah, that sounds good. Okay, purple. All right. So let's write y equals cosine, and we'll put an x. Now we got to find all our missing numbers. Is there an a? Is there a w? Is there a h? And is there a k? Here, let's find out. First, let's do our a. Now, oh wait, no. I think this would be really helpful. Do you guys know where the starting point for a cosine function is? It's right here. That's the starting point. Now you have to know what the mother function for cosine looks like. And you have to know what the mother function for sine looks like in order to do that, which we'll talk about in a second. So that's the starting point for cosine. Actually, here, let me just draw the mother function for cosine. Here's the mother function for cosine. Whoop, 2 pi. See where we start? We start at the max. We start at the max on a cosine function. So this must be the starting point for our cosine function. You see how the cosine function makes like this bowl thing? You see, if we start right here, we could make our bowl thing right here. You guys see that? There's your cosine function. Okay, so what is my amplitude? Is the amplitude the same as sine?
No.
No. Okay, count the distance from the midline. Here's my midline. If I count the distance, is this still 10? Or, I'm sorry, is this still 4? Yeah, it's still 4, so amplitude's the same. We're cool. All right, what about my period? Is the period finished after pi? Yes, the period still finished after pi, so the period still equals pi, so I'm still going to have a 2 right here. But this time, the 2 needs to go outside the parentheses. Actually, let me rewrite that. I'm going to get rid of this right here, and I'm going to put this, I'll give myself a little bit more space here. So I'm going to put my 2 right there, and then now I have my h is going to go right there, and then my k is going to go right there. Let's put a plus sign right there. What is my horizontal shift? Okay, now, hopefully this starts making it make more sense. Look at our starting point. Our starting point is usually on the y-axis. So how much do I have to move over to get to this point from the y-axis?
2.
Okay, you're counting 2, but you forgot our units. Look down here. See down here? If this right here is pi over 2, what is this right here? What is between 0 and pi over 2? Yeah, pi over 4. So it looks like this point moved to the right pi over 4. You guys still with me?
Yeah.
Okay, so if we move to the right pi over 4, how would we write that in this equation?
Minus.
Yeah, you got to think opposite, so we're going to say minus pi over 4. Don't worry, we'll do more examples if you guys aren't getting this.
I got it.
Okay, now the vertical shift. Is there a vertical shift? Did we move up or down?
No.
No? Okay, so let's get rid of that plus sign right there. We're done. This is what it would look like if it was cosine. Now you could simplify this some more just by distributing this 2. So let me show you guys what that looks like. 2x minus, what is 2 times pi over 4? Here, I'm going to do it on the side really fast for those of you guys who forgot. If I do that, then I would get 2 pi over 4, which would simplify to pi over 2. So this would be pi over 2. Then we have cosine chilling right here with the 4 multiplying to him. That's another way to write the cosine function because I distributed the omega into those, which is kind of nice. There's less parentheses, I suppose.